Start. Day 8. Advent of code. Haunted wasteland. You are still riding a camel across a desert island. When you spot a sandstorm quickly approaching, when you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled maps. Sure enough, it's full of documents and puzzle input about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contain a list of left-right instructions, and the rest of the documents seem to describe some kind of network of labeled nodes. Seems like you are meant to use the left-right instruction to navigate the network. Perhaps if you have the camel follow this instruction, you can escape the haunted wasteland. After examining the maps for a bit, do not seek out AAA, CCC. You feel like this is where you are now, and we need to reach here. The format describes each node or the following individually. For example, starting with this, you need to look up the next element based on the next left right instruction in your input. In the example, start with A and go right by choosing the right element of this one. L means choose the left element. By following the left right instruction, you reach the in 2 steps. Right and left. Of course, you might not find this way. If you run out of left right instructions, repeat the whole sequence of instructions as necessary. For example, here is a situation that takes 6 steps to reach. Follow the how many steps are required to reach. Okay. Minimum steps, right? So input. Okay, this sequence is also given, right? Okay, we just need to follow this one by one, and after some time we need to find out what is the this is a graph with left and right nodes, so it may contain a cycle and we start here. Then after some point we may arrive in a cycle, and this path is already given. 6 steps means this thing. This 2 times, right? So BB, then A, then BB, then if we take the left, then we take the left, and first we are here, then we are here, then we are again here. Then we here. Then we take this. I can apply brute force, but this number of pages seems to be large. So this will create some graph which will have cycles and self loops and so on. And essentially we have to traverse the sequence one after the other. So LLR, 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 so on. And is this always the case? Let me start the question. Okay. Even for this, I guess. Easy, where is it? No, it doesn't have an ending. It's not like a leaf node. We'll try the brute force. Let's not over optimize it. Sometimes, like in the form of optimizing it, we forget that the question may not be demanding an optimal solution. Answers for this out 1, 2 steps R and then L. So 2. Answer for the second test case is 6. We need to do this until we find we need to take that input, right? So let's do map of string to string, left, right, and as long as they have some lines, let me put this in input. Say it is a string ULR CULR left of use L, right of use R. What's the issue? Let's do this infinitely. ID is 0. Current is A. While current is not equals to ZCZ, let's do ID mod equals to N. Then if path of this ID is left, current is L off current, else this is path of ID is R, current is right of current, else we can assert false because there is this should not be present. ID plus plus, and I want to keep track of the number of iterations, right? Path length. And so let's try this. I haven't taken input. Seems to be working. Let's try it on the last test case. I need to change this. Control V, go down, delete. Control V, go down, replace with space. Control V, delete, then the same for this character. Fine. Let's try this answer. Let's go over the second part. Before that, copy this part 1. Sandstorm is upon you and you want until you're closer to escaping the wasteland. You are following the instruction, but you are barely left. Your barely left. Your starting position is going to take significantly more steps to escape. The map isn't for people. What if the map is ghosts? Are goes even bound by the laws of space-time. Now, after examining the map a bit longer, your attention is drawn to a curious fact: the number of nodes with the names ending in A is equals to the number ending in C. If you were a ghost, you probably just start at every node that ends in A and follow all the paths at the same time until they all simultaneously end up at the nodes that end with A. For example, here there are two starting nodes, this and this, because both are each left right instructions use the instruction to simultaneously navigate away from both nodes. Currently only pick this person until all of the nodes you're currently at. For all of them, okay, we have two starting points. For each of them we keep track of what node we are currently on, and after each iteration of this following this path, we keep the states of current node for each of them. And if all of them reach at a point whose all of them are at a node for which the last character is Z, then we need to stop it. If only some of the nodes you are currently are on Z, then act like any other nodes, and you continue as normal. In this example, you would proceed as follows. And so in this example, you end up currently tell your nodes that after 6 steps. I will be using brute force only, so I don't want to over optimize this anything. Just try to implement whatever they have asked. Simultaneously start how many steps does it take before. Fine. Question is quite clear. And now instead of current, we maintain list of currents, list of string current. Then this should be, what did we have? Let me store all the nodes, unique nodes in this set. Nodes dot, but it should be okay, right? It should be only the u values, right? So yeah, we can do that as well. So nodes dot insert u, and okay, this is not even needed. Fine. So let's do this. Make current global, then initialize current then and there whenever we are taking input, and the condition is that only the last character is A, right? So if u dot back is an A, we consider that node as the starting position. Then let's say ending condition reached for that particular set of current nodes. So let me write this function, which is all the nodes should be ending in Z or current in current. Let's say u in current, it should be string. All of them should be, hence we take ampersand bitwise and dot back is C and return. Okay, let's also do a bit of silly optimization. Right, so if it becomes false at an iteration, we simply return false because there is no need to check for all the nodes after that. Now path length is fine, id is fine. Now we need to do this for all the current nodes. So let's do C. Incorrect. If you want to go left, do this. This should be changing C in place. I have taken this as a reference. That is fine. Else this looks good. What was the answer? Okay, they haven't given a separate test case for this, but the answer for this test case is given as 6. And I hope this is correct path length, changing the state of all the nodes, and this will running this for loop will change the values for them inside the list items. So let's do in 3. This is done. Let's also create out 3. It should be 6. So lots of p. Answer should be 6 for this as well. And the first 2 test cases should fail because I don't know the answer for them. Okay, for all of them the answer is 0. Until this condition is not met, we need to run that loop. Okay. Don't know why the first 2 test cases also passed, but that's fine. Trying it on the last test case. Okay, if this is slow, then it might be a difficult problem to solve in general. Looks like it is not the intended solution. It has to do something with a repeated pattern which occurs after every some frequent interval. So for this test case, if we trace the path for 1, 1a and 2, 2a, then we get 1, 1b, 1, 1c, 1b, c, 1b, 1, 1c, then 2, 2c, 2, 2c, I'm just looking at these two columns. One thing to note here is this is stuck in some loop, right? So 11B, 11Z, then again 11B, 11Z, and so on. And this is a loop of A, B, C, Z, B, C, Z here. And that loop has length 3, and this has loop length 2. So the LCM of both of them would be 6, hence the answer is 6 LCM, because if some pattern occurs, let's say there are 3 sequences and both of them occur, let's say 6, 7, and no, let's say 2, 3, and 6 times after every interval, then they will match at their LCM. They will converge, or the entire pattern will repeat after their LCM values, which is the least common multiple. But how do we figure out this 11B, 11C? To do that, we for this sequence we are given two length path. Let me get this. Let's write some observations. So the 0, 1 values are the length or iteration mode, the length of the sequence. So first two, we are currently here, which means that we have performed 0 iterations and we are currently at this character L, 0 index. And 1 means that we are currently at this character and we have these two nodes to consider, and so on. Then for the third, we again start from the first character, which is index 0. Now, if you look at these two, so if you start at the same character or the same index, not characters can be same at multiple locations, but if you start at this particular index and you have the same node, that means you are performing the same, you are basically initializing the path from that index, from that node again. So you started at that location with 11B, then you reached again at that location with 11B, and after that the entire string will follow the same direction. Hence this 11B will give us the hint or say that this is repeated now. So 1 and 1 1b is repeated, hence the cycle which will be considered would be this length. 1 2 3 4 5 6 7, and here it is, let's say 0 to a. Let's forget about these ones as well, just for understanding. 0a, 1b, 0c, nothing is repeated. 1c, but then comes 0b, which is repeated, no, which is also not repeated, but mm, what do we see here? The pattern was like B, C, C, right? But still, that doesn't help us with knowing that where we need to end of uh, iteration, right? We know that we need to end the iteration for a when it reaches a value of z. So in this case, it has this all of these choices, right? To stop individually, choices for first at, so these are the rows. I will add a 0 here, and this, so this is, let's say, row number. Then choices for the first are at row 3, row 5, and row 7, and so on. And choices for second were 4 and 7. And if this would have continued, we would have more of this. So I'm looking at the row number for which current node is 7. Sorry, C. So essentially this is what we are doing, and we need to find a common element in this, right? So there can be multiple sequences in here which would have different values in them. Let's try to print answers. So we check in this particular iteration, where are all of them? So Let's do it like this. And we the iteration and rest of the values. So from 2. Plus input was this 3. Okay, so we had, where do we start at B? Okay, because we are printing after we have updated. Okay, let's do it like this. A, B, C, just like this. A, B, C, B, C. Right, so this pattern does follow one of together or link 2 after this one. And here it is A, B, C, B, C, B, C, C, then B, C, C, B, C, C, and so on. So there is a pattern length of 2 here and 3 here. Answer is 6. But how do we find out what is this pattern? I don't think there is the repetition of pattern or something. We simply find out what is the first time Z comes into picture in this particular path, and it has 3 jumps. It has made 3 jumps to reach this and 2 jumps to reach this, and the answer is LCM of them, like so. So let's try that logic. So what we wanted to do is I want to find for each of those strings when they. So this is the starting position, starting node in the current set of nodes that we have, and let's say we're looking at C equals to start, while C dot back is not equals to say, we will store an ID for that, and this is what the loop will look like. We check the same thing. As long as we don't have a terminating position, we also keep track of the length. And for this particular thing, the length would be answer should be initialized with 1 to take the LCM. Yes. That equals to LCM of answer comma length, and print answer return 0. Let's comment this out. Write LCM M of A and B is A times P divided by the GCD. Okay, I think I have missed one thing. This should be C. Fine. Let's try. I forgot to change this ID as well. So ID equals to ID plus 1 mod n. Check on last test case. Answer seems to be very large. Let's try it out. Fuck. So yeah, it. I didn't expect this to be correct, but it's fine. So main idea was to check when this pattern repeats. So we found out that in this sequence of, so this one, A, B, C, B, C, B, C, G occurs first time at the third position, which is after 2 jumps, and it occurs at the fourth position for this second starting path. Hence this, they will occur at the sixth position or 0, I mean after 6 jumps for each of them, because we take the LCM, and LCM is the first point for which they will be intersecting. Okay, fine. Let's copy this to solve part. What's PP? Nothing to refactor here. Here I will remove this part. Let's see, everything looks fine. I also don't need this terminating condition. Sim is fine, input is fine. In 1, in 2, in 3. 3. So rest. So that's it. This is first, second solution. This first, and okay, I'm keeping that. Let's add some pointers here. Jump for each starting point, starting node. Jumps required for each starting node to reach a terminating node for the first time. Okay, git add, git commit. Git push. That's it. Thank you for watching. I'm closing the stream.